It's not very full here. As I know, printing is not very attractive, but it is important, and I'm the one who makes it just work, and I want to tell you what you as an application developer have to, or GUI developer has to do to make it also just work. So it's about the new architecture, mainly of printing, but also a little bit of scanning, because and at first it will have 4 sections. Once I will introduce into the new architecture of printing and scanning. Then I will tell about printer setup tools and how the design of a printer setup tool has to be for the new architecture, and what is the progress on the work on the new Gnome Control Center printer setup tool. After that, I will talk about print dialogs, what there has to change, and what the ideal solution is. And in the end, I will also talk a little bit about distribution-independent packaging. How one can package cups, how one can package applications, how one can package printer applications. Printer applications are drivers, is the new printer driver format, and applications, user applications, are these programs out of which you want to print. So this was the overview. So the new architecture, for 22 years now, since its 1.0 launch, CUPS uses principally the same architecture. We had in the beginning PostScript standard job format as printer typically used with Unix were PostScript printers. You remember the university, the computing center there, and the laser printers, and they all worked with PostScript, and the workstations simply sent PostScript, and this worked. And the capabilities of the printer, what is different at the printers, which trays they have, which resolutions they have, which paper types they accept. These were for PostScript printers. It's designed by Adobe. PostScript is designed by Adobe. The PPD files are designed by Adobe. For the printers, they describe the capabilities, which trays they have, and which paper types they accept, and so on, user settable options. It's all in a text file, in a PPD file. And so CUPS uses this PPD file. For PostScript printers, it uses simply the PPD file which comes with a PostScript printer. And for non-PostScript printers, Michael Sweet, the author of CUPS, has done simple extensions. He has simply added a line to the PPD file named CUPS filter, and in this line it is told which filter has to be called to turn the input into the printer's native format. And so in CUPS, non-PostScript printers worked also with PPD files. PPD file means PostScript Printer Description file, because for this they were originally designed. And the filters which CUPS uses for non-PostScript filters, they usually use somehow GhostScript. Either GhostScript with a built-in driver, or at first GhostScript makes CUPS raster out of it, and then another filter makes CUPS out of CUPS raster the final format of the printer. And you usually, with a printer setup tool or LP admin command or a web interface, you created manually a print queue. You had to select one of the discovered printers, USB network, and then you had to select make and model of the printer. Later on, this worked automatically by the printer hardware ID, and with this, a PPD was selected, and the PPD contains which driver is used. And why do we want to do away with PPD files? It all looks nice, it all worked for 22 years, why do we want to change? So in 1984 already, 16 years before CUPS 1.0 was available, Adobe stopped the development on PPDs, so CUPS used a completely obsolete format. It worked, but it was obsolete. So we started so in 2006, Mike Sweet and me, we abolished PostScript as print job format and replaced it by PDF because we were in a world where we have very many non-PostScript printers, and also PDF has transparency, is not a programming language, so cannot contain malicious software. And so PDF is much more modern, still under development and maintenance of Adobe, and so we switched to PDF. In 2006, in Atlanta, Georgia, in the first OpenPrinting Summit which I've organized. And the PPD files can represent user-settable options only as enumerated choice. So page size is A4, A5, letter, A3, legal, and so on, or as Boolean. Manual feed on or off. And so if we want to have now a password as an option, so a password is a string, or which you can type in any arbitrary string, or for example, if we want to have a color adjustment, sliders, this does not work with these options. And there are a lot of ugly workarounds by the different driver authors. Mike Sweet has also invented some workarounds for PPD files to get this kind of options and so on. It's all very ugly. So let us get rid of PPDs. Rest in peace, PPDs. So we come to the new architecture. Now we want to go all IPP. We know in modern times, most printers are driverless. They usually support AirPrint, so that you can print with an iPhone on it. And on the iPhone, you do not put a driver. The printer is a driverless IPP printer. MoPre is another standard preferred by Windows. But the principle is always the same. IPP everywhere, another standard. Or every time the same principle, a printer announces themselves in the network by DNSSD. And so the computer finds it, and the computer gets some information, the DNSSD text record with some basic capabilities. And then the printer asks via the IPP, Internet Printing Protocol, asks the printer for its capabilities, a get printer attributes request. The printer answers with all its capabilities, the information which you formerly found in the PPD, in another format, not in the format of PPD files. And especially also which page description languages the printer supports. It must be at least one of the four: PDF, raster, PWG raster, and PCLM, where PCLM is not PCL. PCLM is a raster-only PDF. But one of these formats, so the client exactly knows what he has to do to print on this printer and which options to show in the print dialog. And so we don't need a printer driver. Printer driver means any software or data which is specific to the model of the printer. And so we have driverless printing. And so in CUPS 3. And most modern printers support it. So if you go to your preferred supermarket and buy a printer from the promotion, it is usually driverless. So you don't need to worry much about which printer to buy. So from CUPS 3.0.x, it starts end of 2023 in time to get into Ubuntu 20.4.04 LTS, the next LTS in 2 years. Then we have CUPS 3.x, and this CUPS will not support PPDs anymore. It's IPP only. It supports only driverless IPP printers. And now you think, who has an old printer, has lost, he cannot install a driver anymore. So we have also a new format for drivers. It's the printer applications. A printer application is a piece of software, a daemon, which emulates a driverless IPP printer and internally communicates with a non-driverless legacy printer or specialty printer to print on it. But for CUPS, CUPS sees a driverless printer on localhost. And for all the drivers which you can get for Debian as free software, I've already converted them all into 4 printer applications, which you find in the Snap Store. And so we have now only driverless IPP printers supported, and we cannot manually create queues anymore because CUPS, already the CUPS of now, if you have a driverless IPP printer, automatically creates a temporary queue. And therefore, when we have only driverless printers, we don't need to manually create CUPS queues. So the new CUPS will not support that anymore. And filtering is only done to arrive at the driverless standard formats, because other formats are not needed anymore. And as I say, when the printer is not driverless, then we use a printer application. And here are the schemes. This drawing is from Michael Sweet when he introduced CUPS 3.x on the last Linux Plumbers conference. And the old way is you have a user application, sends a job to CUPS, and CUPS does the dirty work alone if the printer is driverless. It uses a PPD file, only a PPD file if the printer is PostScript, and it uses PPD file and printer driver if the printer is non-driverless, non-PostScript. And in the new architecture, CUPS itself only can do IPP, and so it either communicates directly with a driverless printer, or it needs a printer application which needs to support the printer. There are several different ones to print on non-driverless printers. So for this, a printer setup tool, how it comes with the distros like System Config Printer, will not work anymore and will not make sense anymore. So the CUPS web interface will still work, because when you have a new CUPS, it has a new correct web interface to work with itself. LP admin will not be needed anymore, as we do not create manual queues. And here system config printer will not work anymore. CUPS browsd will be later on turned into a printer application so that one can at least use it as cluster manager. And Gnome Control Center will be completely changed. I'll talk about this later today. And yeah, the print module of Gnome Control Center, not the complete Gnome Control Center. And these tools control CUPS, the one in CUPSD. These old tools, they list the available queues and the available CUPS queues. And when you want to add a printer via Add Printer button, it does detect printer, make and model, and find PPD for it. And the printer management for the new architecture. At first, the new architecture we have beginning from CUPS 3.x or newer, or also if we use the already existing CupSnap, because the CupSnap is totally encapsulated, you cannot add drivers and PPDs to it, so it behaves like a CUPS 3.x with only supporting the new architecture. And all printers are driverless IPP printers, as I said. And so the tasks of the printer setup tool is listing the IPP services. This means we list all the IPP printers which we see in the network or emulated by print applications. And in the list of IPP services, we have buttons to open the web admin interface. Every printer and also every printer application, which is IPP, has always a web interface. Also supports IPP system service. It's an interface to configure IPP printers. And so we have buttons to access these facilities for each IPP service. And if we have a multifunction device, it has two IPP services, printer and scanner, we list these components together, and our printer setup tool allows this way also configuring the scanner. And discovering and the add printer window is discovering non-driverless printers. Here we discover printers as we did before, but we do not find a PPD for them. We send the device ID to the OpenPrinting web server, and there we will have a service which knows all the printer applications which we have, and this service will answer back a list of printer applications which support this printer in desirability order. And so the printer setup tool knows which printer application to install from the Snap Store, configures the printer and the printer application, and then the printer is an IPP service and appears in the main window. And so we have similarities. All main window, old CUPS queues, and buttons to set the options, and new IPP services and buttons to get into the web interface and into the IPP system service. And the add printer window, old, lists the discovered printers, find make, model, driver, PPD file. New, list the non-driverless printers, and ask OpenPrinting which printer application to install. And for multifunction devices, as I said, we list not only the print IPP service, but the scan IPP service and perhaps fax out all together. And so scanners and faxes are treated like printers and appear in the printer setup tool. And so now we have the IPP Service List Manager GUI. This is the main screen of the Gnome Control Center printer module. And here it got coded in the Google Summer of Code 2021 already. And it is naturally GTK Plus based and ready for inserting in the Gnome Control Center. It discovers the services using Avahai, and it checks for duplicate entries and removes them so that all is nicely sorted and user-friendly, printer and scanner also together, and has buttons for the device's web interface. Then in 2020, in the Google Summer of Code, another student has written the IPP System Service GUI. So this student has written the dialog which is opened when in the list of IPP services, you click the button for the IPP System Service. It's also ready for being added to the Gnome Control Center. And now we need still a tool to guide the users setting up non-driverless printers. And this is planned to be done in Google Summer of Code 2022, this year. And naturally only under the condition that we get enough slots from Google, so that we can accept the student who has applied for this project idea. And so this is replaces the former add printer window. We discover all non-driverless printers on USB and in the network. We find printer applications, check also which printer applications are locally installed, perhaps we have already the right one, and for finding out which printer applications are in the Snap Store, we use the service on OpenPrinting. This we have to do, it's a workaround, because I've done a feature request to the Snap Store for searching snaps by hardware signature, and no one has worked on that. And so and with this way one can easily set up the printer, the printer application for the printer. And here we install the printer application, which OpenPrinting tells us which is the right one, and install the printer in the printer application, and then we will after that see the service, see the printer's IPP service in the main window, and we can print on it. And what we still need for the printer setup tool, once it's the third component, as I said, the add non-driverless printer. We have also to put all the three components together, so that we get one new printers and scanners Gnome Control Center module. For this, if all works nice, we will get a second Google Summer of Code student this year. And this second Google Summer of Code student will work closely together with our desktop team at Canonical and with the design team, so that we finish up a nice module to submit upstream. And in the middle of the project, I will be on the GUI deck in Mexico, and there I will give a report in my talk there, which is otherwise similar to this one. I will give a report on the progress of that. And now you know the situation of the printer setup tool. And the next thing are print dialogs. Print dialogs also need to work with the new architecture. And the most important thing is, at first, they need to support temporary CUPS queues. These queues, which CUPS and the CUPS clients automatically create based on discovered IPP printers, which are created only for the job for doing the print job, and removed 1 minute after the print job is done. And many print dialogs still do not support them. Fortunately, the GTK dialog has it already fixed. But there are many print dialogs. There's the Qt dialog, there's the LibreOffice dialog, the Chrome, Firefox, and I don't know whether really all of them are fixed. So everyone who is responsible for a print dialog should check this and fix this. And another point is, on CUPS 3.x, there are no PPD files at all. If you have the current CUPS 2.x, even if it's in a snap, you can, with some API, download the PPD file from CUPS. This is not possible anymore in CUPS 3.x, because it simply does not support PPD files anymore. So in this point, the print dialog has also to be checked that it does not try to download the PPD file of the print queue from CUPS, because this is not possible anymore. And even it should also not try surrounding caps by directly getting to HTTP localhost 631 printers qname.ppd. And so these 2 points have to be taken into account, that the print dialog will make it also working on under caps 3.x. But we can make it much better, because now we have to fix the print dialog in all these print dialog in these 2 points. But later on, something will happen. Perhaps something else will be changed in the print architecture, and the print dialog stop working again and need to be fixed again. And also, it can happen that there's a new cloud printing service. And it would be nice if the print dialogs support this cloud printing service too. And therefore, we want to do it better. We do the so-called, we separate the support of the print technologies like CUPS or print to file or like any cloud printing service into so-called print dialog backends. And the backend supports the print technology, is connected by dbus with a dialog with the front end. And so the dialog does not need anymore take care of changes in CUPS and so. And so the creators of the dialog, the GUI toolkit developers, do not need to keep pace with it, which is especially difficult because they have also rather long release cycles. There's low motivation to maintain the print dialog and so on. And so we separate this. And this we call the Common Print Dialog Backends. It was already developed in the Google Summer of Code 2017. And it follows a development, a former development. Formerly, we tried to do something different. Instead of adding, we tried to get a common dialog provided by the desktop, the print dialog provided by the desktop, and not by the application, so that all applications have the same print dialog to make it easier for the user to see always the same print dialog. And this we called Common Print Dialog. But we failed with it because we did not have enough people to code on it. And later on, but one thing is interesting. We failed on it, on this idea, but this idea did not die. The Flatpak people had the same idea, but with another background to let the system, the desktop environment, access the user's files through the dialogs, but not only print, but also open and save. And this way, allow the encapsulated application in the Flatpak access the user's files. I don't know whether the Flatpackers came to the idea by itself or whether somehow they found my idea of 10 years ago. It's all free software, so they were not obliged to ask me. So, and later on, we looked into perhaps reviving this idea, but in the end, we came up to the mentioned Common Print Dialog Backends, not Common Print Dialog, meaning that we leave the dialog with the application, but the dialog does not support CUPS and print to file and cloud print services by itself, but shouts into the dbus, and the backend support CUPS and print to file and the cloud print technologies. And so for CUPS, OpenPrinting can take the responsibility of the print dialog all working with CUPS. All print dialogs always working with CUPS. And And so, OpenPrinting would always update the dialog for, backend for cups and for print to file too. And if someone offers a cloud print service, they would also issue the Common Print Dialog Backend for it, maintain it, put it into the Snap store. And if someone wants to use the service under Linux, he installs the Snap with the backend. And this way, all print dialogs show the printers in this cloud print service. And for this, we have already the dbus interface, we have back-end and front-end libraries. The only thing which is missing is that the print dialog adopt the Common Print Dialog Backends system. And we have also a Google Summer of Code students, a project idea. Google Summer of Code contributors do not need to have to be students. And if we would get enough slots, we let a student work on this, a contributor work on this. So this I have already told. Here's the scheme. This is an original drawing from the Google Summer of Code contributor who has started on this project in 2017. So we go directly to the application distribution. And I'm now on the wrong direction here. Snap. Yes. Yes. One thing is, another thing is we have distribution independent packaging. There is Snap, there's Flatpak, and there's UpImage and Docker and so on. And for printing, and one thing is we have Snap cups, we have Snap printer applications. Snap seems to be the most sophisticated. One can snap package system daemons, but one cannot Flatpak system daemons, one cannot put system daemons in an UpImage. And so cups exist only in a Snap and not in other distribution independent packaging formats. Same for printer application. And many people are complaining about snaps. There's only one snap stores, monopoly and so on. And they are slow in startup and so people are complaining. And I want that one can get cups also in another format. And I reviewed Flatpak and UpImage, and they seem to be only for applications. For example, Flatpak interacts with the desktop to access the user, to access the user files, and then one cannot really run them as root. And UpImage has no security concept; you cannot run this as root too, and so they are not suitable. But I talked with the Flatpak guys, and there's a trick that one can make a Docker container of cups, so that I will do in the near future an official Docker container of cups. There are many unofficial third-party ones from people who have uploaded them, and I will make one which is really coming from OpenPrinting and as universal as possible, and not containing drivers. Is the problem, as driver support we do not need anymore, as we have print applications. And with this, there's a way that when we have a system which is Flatpak based, we can somehow get the Docker container in, or directly when we have a server where we want to simply use Docker, we can use the Docker container too. And so we will have a second way to provide cups as distribution independent package. Same for the print applications. But the print applications, perhaps I can do another trick, running them for Flatpacking them, running them as the user, and letting them started when he logs in and letting them stopped when he logs out. I have to look into this too. So this is distribution independent packaging of cups and cups and printer applications. And I also, in Snap, have integrated the cup snap completely into Snapd with an own interface named cups, so that if you snap an application, a user application which prints, you can securely print, and it is not possible for the application snapper, the application packager, to let administrative requests like creating queues, deleting someone else's job, reading someone else's job by the application through this interface, and so it's secure. So this way, the developer, the Snap developer, can upload it in the Snap store, and as it's not dangerous, he does not need permission from the Snap store team. He can simply upload, and his application can print. And for Flatpak, we have something like the Common Print Dialog, so it just prints. And for app image, we have no security shell around the application, so it just prints too. But app image, be careful. It can also administer cups and mess up your queues and app image. But Flatpak, as it goes through the print dialog, Flatpak itself is protecting against administrative requests to cups. And that's it.
All
Any
right.
question?
Yeah, we got applause first.